ఓకే స్టూడెంట్స్, ఇప్పుడు గేట్ 2024 ట్రిపుల్ ఈ పేపర్లో 17, 18, 23, 32 క్వశ్చన్స్ చూద్దాం. ఫస్ట్ క్వశ్చన్ 17 చూడండి. క్వశ్చన్ చదవండి ఫస్ట్. 3 ఫేస్ 50 ఎడ్జెస్, 6 ఫేస్ 6 పోల్ నాట్ ఫేస్ అంటే పోల్స్ 6 ఉన్నాయి. ఓన్లీ ఈవెన్ నెంబర్ ఉంటుంది తెలుసు కదా పోల్స్. Induction motor runs at 960 rpm. The stator copper loss, core loss and rotational loss neglected. Stator copper loss లేదు, core loss లేదు, rotational loss లేవు. What is the percentage efficiency of the motor అని అడిగాడు. సో ఏమి ఇవ్వకపోతే ఏం చేస్తావు? హియర్ స్పీడ్ ఇచ్చాడు. ఎంత ఇచ్చాడు? 960 rpm ఇచ్చాడు. సో with this speed, what do you do? And also 50 edges and a 6 pole 3 phase. Ive ichche data. How can you find efficiency? For efficiency you need output power by input power. So how can you calculate? There is no rating of the motor and also there is no any load. At what load you have to find? So I found an equation at the time of my diploma studies at around 1993 or 4. I saw an equation as a relation between rotor output, rotor loss, rotor input. I saw a relation between output, rotor loss, rotor input. So, and also I derived it. You can derive with the approximations is equal to 1 is to s is to 1 minus s. This is the relation between the rotor power input, rotor loss, rotor power output. So now what is the efficiency? Rotor output by rotor input into 100. See, now this power relation with the slip. What is slip? Ns minus n by ns. N is the normal speed, ns is the synchronous speed. So how can you find the synchronous speed? 120 f by p. 120 f is frequency, p is poles. This is 1000. So what is the slip here? 1000 minus 960 by 1000. So this is the slip. This is 0.04. Now what is power output? 1 minus s. Ratio, it's a ratio. Power input to the rotor 1 into 100. So 1 minus 0.04 into 100. This is 96%. Efficiency of the ఇండక్షన్ మోటార్ ఈజ్ 96%. సో ఈ రకంగా నువ్వు ఫైండ్ అవుట్ చేయాలి. నౌ ద సెకండ్ క్వశ్చన్ ఈజ్ వెరీ సింపుల్, వెరీ ఈజీ, అండ్ యూ మస్ట్ ఇన్బిల్ట్ ద థింగ్స్ ఇన్ యూ, అదర్వైజ్ యూ విల్ ఫీల్ హార్డ్. రీడ్ ద క్వశ్చన్. విచ్ వన్ ఆఫ్ ద ఫాలోయింగ్ option represents possible voltage polarities in a single phase 2 winding transformer? Here primary voltage, this one, this is induced voltage, this is secondary voltage, ES is secondary induced voltage. See, keep this aside. You must here now Which of the following option represents possible voltage polarities in a single phase? Voltage polarities. See, whenever you, what voltage polarity here we represent in two ways. One positive and the other is dot convention. Dot convention and positive and negative. See, if this is positive, not this, if this is positive terminal, this is negative terminal, the dot was marked at the negative of the primary, negative terminal of the primary. Same way, this combination also must be maintained in the secondary. You must also, this combination should maintain in the secondary also. So this is negative dot, here positive dot, this is wrong. See, positive dot, here positive dot, right? And check the other, positive dot, negative dot, wrong. Positive dot, negative dot, wrong. So this is the correct option for this question. Okay, next one. First read the question before going through the explanation. You try it, then see my explanation. Instrumentation transformers features. Instrumentation transformer features. See, current transformer, potential transformer. చూసారా, కరెంట్ ట్రాన్స్ఫార్మర్, పొటెన్షియల్ ట్రాన్స్ఫార్మర్. ఇక్కడ యాక్చువల్గా ట్రాన్స్ఫార్మరే, ఇట్స్ ఏ ట్రాన్స్ఫార్మర్. బట్ వాట్ ఈస్ కరెంట్ ట్రాన్స్ఫార్మర్, వాట్ ఈస్ పొటెన్షియల్ ట్రాన్స్ఫార్మర్, యూ మస్ట్ నో ఇట్. సి, there is a conductor, there is a conductor carrying current. There is a conductor carrying conductor. There is a conductor carrying current of a power system. This is nearly 11 kV and above line. So it carries lot of current because the load is itself having huge. So by using this length, you must design the current transformer and potential transformer. See, let this is 1000 amperes, let, or 100 amperes. We cannot measure 100 amperes by putting an instrument in the line. It's impossible. Suppose maybe 1000 amperes, can't measure by using the instrument because the instrument is very sensitive. We cannot design that instrument for 1000 amperes. So we must do something that just I have an instrument or ampere or voltmeter. So I want to give some additional instrument between these two, then this ammeter will work. Let this is 100 amperes flowing. This instrument will carry, or capable of to carry 1 ampere. So I must step down this current. So step down, step up, step down, step up. How can you step up and how can you step down? See, there is 100 amperes flowing. I want to reduce this current. How? Let this is 10 amperes. 10 turns in the primary. Let this is 1000 turns. What is the current in the secondary? Suppose if primary carrying 100 amperes and I designed a transformer with 10 turns in the primary, 1000 turns in the secondary. So here voltage low voltage because low turns, high turns, more voltage. So low turns, high current, low voltage, high current, high voltage, low current. So step down of the current. So I reduced this to 1 ampere. Suppose this is 50 ampere, then this is 0.5 ampere. According to that scale multiplication factor, I can find the current the actually carrying in the power line. So like this I designed one small transformer. So the transformer used as current transformer. Like that potential transformer also we can design. Okay. Now the property of the current transformer and potential transformer. See, potential transformer, current transformer, what do you do? See these four parameters. Current transformer, primary is connected in parallel to the grid. Primary is connected in parallel to the grid. Open circuit secondary is not desirable. Primary current is the line current. Secondary burden affects the primary current. Okay. If you are if you are thorough with this, then you can directly put that options. Now look at this. CT always short circuited in the secondary because high magnetic field will be induced in the secondary, then the current transformer will be burst. So current transformer secondary must be shorted. That is, secondary is not open circuit, secondary is not desirable. This is okay for this. Parallel, no. Later I'll explain about PT, then you'll realize. What about primary current in the line current? This is a line current I am winding on this, and this is let 100 amperes. This is called 1 turn. This is 100 turns. Then this current flows 1 ampere. Okay. So this is a transformer. This is one winding of the primary, and this is secondary. So in the primary circuit, actual current is flowing. So this is also meant for CT. This one and this one. These two are belongs to current transformer. What about potential transformer? Primary is connected in parallel to the grid. See, this is a line. I want to measure that voltage. So what? So for this is 1000 turns. This is 10 turns. Suppose this is 1000 volts. Turn per voltage is 1 volt. I made the secondary 10 turns, so I get 10 volts in the secondary. So this winding is connected with the grid. This is the grid line, power transmission line. So secondary is less winding, primary is, this is quite opposite to this one. So potential transformers primary is connected to the parallel to the grid, and this one secondary burden affects the primary current. Suppose if you keep load on this, then this current will be affected, so that the perfect voltage will not be measured due to its burden. Okay na? So this should not be overloaded. This should not be burdened with any other equipment. So here current transformer is open circuited, secondary is not desirable. Primary current is the line current. So search where it is. X is for QP. Q P. Sorry, Q R, Q R, Q R. This one. So this is the correct answer. Okay. See this. It's a mathematics question. Even then also you can do easily. Sum of the eigenvalues of the matrix. Do you know what is eigenvalue? Let lambda is an eigenvalue. Then lambda I minus a. Let b, because this is a square equal to 0 is the eigen value. So normally eigenvalue, he is asked the sum of the eigenvalue. This is square. Suppose if a equal to 1, 2, 3, 4, sum of the eigenvalue is 5. Sum of the diagonal elements. But this is a square. A equal to 1, 2, 3, 4 square. 1, 2, 3, 4 whole square is 1, 2, 3, 4 into 1, 2, 3, 4. So this is 1, 6, 7, 2, 8, 10, 3, 12, 15, 3 2s are 6 plus 16. So 22. This is the square of this matrix. What is the sum of the eigenvalues? Sum of the diagonal elements? 29. Or you can find like this. Lambda I minus a equal 0. Lambda 0, 0, lambda minus 7, 10, 15, 22 equal 0. So this becomes lambda minus 7 minus 10 minus 15 lambda minus 22. So lambda minus 7, lambda minus 22 minus 150 equal 0. This is a quadratic equation. You can find lambda 1, lambda 2, then lambda 1 plus lambda 2 is the sum of the eigenvalues, that is 29. This way also you can get the sum of the eigenvalues. So these are the three questions. Any more questions? Yes. These are the 4 questions. Each question carries 1 mark. Then you can, diploma people can get 4 marks now if you write. So this exam is after BTech, but even then also you must be ready for that national level examination from the diploma level, from the diploma onwards. Okay, good luck.